Okay, so this is the
No,
big
just now
one.
I tried to share and it is showing Chrome tab. It is showing that.
Yeah, on Firefox it doesn't show. It used to earlier,
Okay.
but now it doesn't.
Okay. Right.
Okay, so week 9 is all about graph plan in Aostar, right?
Yeah, I think.
AI slides and graph plan. So there's this one thing for graph plan that you need to keep in mind, and that is mutex relationships and the four conditions for that. This is problem decomposition. It's not here, right? It's in week 8. Has anyone watched this 41 minutes video? This is part of the week 9 lectures itself. Gold reef deduction in logic. Has anyone watched
Yeah,
this?
I watched it. I watched it, but I don't remember.
Same case
Was there
actually.
Long back.
anything special discussed in there?
That multi-arm robot, no?
No, multi-arm
Specific
robot is in
which
week 10, I think.
nahi, फिर I'm not remembering it.
Okay, why is week 11 open here? POD automated planning. What does week 11 have then? This is constraint processing. Which slides have the correct one? I think it's just this one. Yeah, mean ends analysis. But this has AOSTA, not a graph plan. So where is
Right.
graph plan? This is week 10 automated
I'm
planning.
also having one query in AOStar as well.
I mean, there is very much graph plan discussed somewhere. I'm forgetting where exactly though. This is week 11. No, sorry, this is week 9.
Graph plan is
This is
in
week
week
9.
9 only, if I'm not wrong.
This one. GSP, Sussman. I think it's at the end of week 8, if I remember correctly. Yeah. Mm, so this is flaws. This is two-arm robot. I did not enjoy planning as much as I enjoyed configuration, I'll say. Configuration was really nice, but these planning problems are not as, what can I say, entertaining. Okay, so graph plan. Yeah, mutex relation. Okay, I'll note these down first. So there are four conditions for a mutex relation. Three of them are named, one of them isn't. So mutex relations, mutex conditions, I'll say. Mutex conditions, and so the first one is competing needs. Competing needs is for two propositions, not two actions. Correct? Because if we there exists propositions PA, that is a precondition of A, and PB, that is a precondition of B, such that PA and PB are mutex in the preceding layer. For A and B are mutex as well. Okay, so this is for actions. Competing needs for actions. For actions A and B, whose preconditions are mutex. pairwise mutex, I'll say. I'm just trying to write the same definitions but in a much more simpler term instead of relying on a lot of set theory notation there. So the next one is inconsistent effects. I think inconsistent effects is just that one has a precondition that is a positive effect while another action has the same precondition that is a negative effect, right? That there exists a proposition such that P is a positive effect of A and P is a negative effect of B or vice versa. The semantics of these actions in parallel are not defined. If they are linearized, then the outcome will depend upon the order. Okay. So yeah, so if there is any precondition P, no, if any precondition is a positive effect of an action, is a positive effect of an action, and a negative effect of an action. Negative effect of another parallel action, I should say. This is also for actions, because if such a thing happens, then we say that A and B are two mutex actions. Yeah. Third one is interference. Interference is, I think, that an action needs a preposition in its precondition, but that preposition is being deleted by another action. That there exists a preposition such that P belongs to precondition of A and P belongs to negative effect of B. Then only one linear ordering of the two actions would be feasible. So if I were to say simplify this in simpler terms, I'll say that if an action needs a precondition
Another
while it is being destroyed by another action, while it is being destroyed by another action. So if such a thing happens, again this is for actions themselves, that A and B are mutex. Okay, this is again for actions. And then there's the last one. It has no name. It just says that there exists a proposition P such that it is a precondition of A and a negative effect of B, and also a precondition of B and a negative effect of B. So that is the preposition is consumed by each action, and hence only one of them can be executed. Okay, so this one can't this fall so the fourth one is a mix of inconsistent effects and interference, right? No, it is just that. Okay, no, okay. So the fourth one is just that P is a precondition of A and P belongs to the positive effects of A while the same thing but for B. So again, A and B are mutex. So when are two propositions mutex? Can two propositions be mutex, or is it just the actions that are mutex?
Propositions also can be mutex.
Yeah, there was a question, so then it should be the case.
Yeah, but according to which of the four properties we can say that propositions are mutex? There exist
First one.
propositions PA and PB such that PA and PB are mutex. Yeah,
So the propositions here, na? These are propositions.
so the propositions are mutex. That is a proposition. So competing needs is saying that if two preconditions, sorry, if preconditions of any two actions are pairwise mutex, then those actions are mutex. But then how are PA and PB mutex?
That
Uh,
we will learn in next 2 3 slides.
Sorry.
That we will learn in the next 2 3 slides.
Okay, okay. So here, yeah, mutex
Next
relations.
next.
This one.
This one.
So two propositions P and Q are mutex if all combinations of actions AB in AI with P being a positive effect and Q being a positive effect are mutex. Okay.
It is
So
like a cycle, no?
yeah, yeah, okay. So if any two any two propositions that are preconditions of any two actions are mutex, then these two actions are mutex. The
In
same
the
way,
previous layer. Yes, in the previous layer.
yeah. So here this means that if any, so this layer has propositions and these propositions are a positive effect of some action. That pickup C is adding hold C. So hold C is a positive action of pickup C. Similarly, hold A is also a positive action of unstack AB, correct? And we know that pickup C and unstack AB, let's say that these two are mutex actions. So because of that, their positive effects are also mutex. Yeah, that's what basically means.
Yes, we have to check for all combinations of A and B. All
No,
combination
we
of
have
two.
to, like if we are looking for mutex, if there is even just one such pair, then it's mutex. If we are wanting to say that this is not mutex, then we have to find all such pairs. Then we have to check all pairs. Yeah. But if we are saying that this is mutex, then even finding one such pair is enough. Oh no, it is saying that P, Pi and Q, Qi are mutex if all combinations of actions AB in AI with positive effects are mutex. Okay. So all pairs need to be mutex. Only then P and Q are mutex. This is saying. I think I got the
Including no op.
yeah, including no op. So what I said was wrong. I think I got the thing reverse. So if all pairwise actions are mutex, then P and Q are mutex. Yeah.
Yes.
Okay.
Oppositely, uh, if there exist two pairs such that non-mutex, then we can say these two propositions are not mutex.
Yeah. If there is even one pair of two actions such that these two actions are non-mutex, then we can say that these propositions are non-mutex. Yeah, okay. So that is the main thing for AO star. I don't think I can write anything for AO star because AO star is an algorithm and that thing grows similarly to how the other tree algorithms grow. It's just that it has the concept of something called an AND node. Yeah, this AND node here. And whenever we arrive at an AND node, let's say I arrive at B. So once we arrive at B, why is this also okay? This should be D. Okay, there's some mistake here. I think these two should have different labels. I'll copy this. I copy this color and click on. Okay. Let's say I'm calling this D here instead. So what we do here is that when we arrive from G to A, yeah, so we just explore A. We because there is nothing more down there, we just end here itself, correct? Because there is no more branches that are coming from A. So this is where this subtree ends. But if we were to come to D from G, what would happen is that D is an AND node, and to say that D has been solved, we have to solve both B and C. Yeah. So only when B has been marked as solved and C has been marked as solved, we can say D is solved. Am I correct in that? It might not be the same terminology that we say that this node is solved, but it's a similar concept. Maybe we can go through that. Maybe we can check that through some example in the lecture itself. The professor goes through an example, right? This example.
Yeah, that example is handy actually.
Yeah. So is this a solved example or this can be solved? This can be solved, right?
This can be solved. Yeah.
It is not.
because
This
we
one is
already
the
have the
this is the steps. These are the steps.
Okay.
we
Okay.
already have such steps so that we can follow them
Yeah.
to learn.
But you know what? That example is comparatively easy. But the one which Amitabh had posted for that in that paper one, which I had asked a question yesterday to Amitabh, in that I'm not understanding how to go about it. See, generally what we do is if there is or and there is and, so we evaluate both the things and whatever is having least cost, we take that. That is
Yeah.
understood. If going ahead, that and thing, like here it is 4 and 5, right? So after that 4 and after that 5, there are certain things. How to go about that? Is it based on the least cost? Because over there, the answer is not based on the least cost. That's my question.
Okay, I'll try to see what my
Go through this
understanding
first.
is because I too haven't solved this properly. So this is
Okay.
also my first time going through A star. So I'll be A star. So I'll be relying on others as well, like who studied this, who solved the
Yes.
weekend assignment, right? So what is
Yeah.
the
What we can
first step itself?
First step is that this approximate cost is 21, like estimated. So we
Yeah.
have to check. There are two and things. एक 6 7 वाला है and the other is 4 5
So
वाला.
this is
So we have to
13.
check.
This is 9, right?
Yeah. Not 13. Age cost is 1. So
Edge
6
cost
plus
is 1.
oh
Okay, so this is
yeah 1
15. This
1
is 11. Yeah.
6, yeah, exactly. So 11 is lesser. So we have to go to the 4 5 thing, that 11 thing.
Okay, got
We
it.
have to consider. We have to expand that particular thing.
Okay, so we expand this and we explore the AND node from the left hand side first, right?
Yeah.
That we
I
try,
don't know whether left or right. I don't
we
know that
solve
thing.
4 first or no, I think it's based upon
five.
the smaller one, right?
Least cost. That's what I was assuming, but in the exam thing, I didn't see that. That's why I
No,
was
I
going.
think we should go when we take and the node, we have to take
Hmm.
the maximum one.
The maximum one, okay.
Oh, is it? Oh, then that's fine. Then it was my understanding which
Yeah,
was wrong.
there's a min
Okay.
or max condition here. So we explore the max one, that is
Ah.
5 here, right? So the solved nodes have cost 0. Am I correct in
Yeah,
saying that?
yeah, yeah.
Okay.
Yeah, in this particular case, they have said that solve last nodes are having cost 0.
Yeah.
So
So
we have
we
to just
move
consider
on.
the age cost. Age
Yeah.
cost.
So we move on here, and by sitting here, we see that this is cost 2, correct?
Perfect. Yeah.
Yeah. Then we
Yeah.
go to this node.
No, 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 no. एक minute.
They are already leaf nodes.
You are already at leaf node. Na? So cost that particular age ka cost you are saying then it's only one, not two.
Okay.
Together that and thing is two.
Okay. Okay. So firstly, what we do is that firstly we come here right now. Okay.
Correct.
That we come here, we go down there
Hmm.
because again this is an AND node, and we see that this is
Yeah.
0. Yeah.
Yeah.
So we mark this as 1. We again
Yeah.
go backtrack. We again backtrack and go up. So once we come here, we see this is 0. So then we again
Yeah.
backtrack, we come here, then we go again here. We see that this is also 0. So
Yeah.
we know that this is
Instead of
just 1 plus
five,
1, 2.
yeah, instead of five, it two will come over there.
Yeah, so this becomes 2.
Hmm.
that this is 2, and now
Yeah.
this change is again propagated upwards.
Yeah. So it will become 8. Instead of 11, it will become 8 now.
Yeah,
Because 4 plus 2 plus 1 plus 1.
yeah. So now this is 8, and this
Yeah.
should still favor 8 here because that's the lower one. Yeah,
Yeah, that's that 21 will become 8 now actually. That 11 you're talking about now, that 11 was over, but at 20, we have overwritten 21 and put 11 over there initially because 4 plus 5 plus 1 plus 1. Now after doing solving this 5, it has become 2. So now the instead of 21, it will become 8, instead of 11, it will become 8 now. Yeah.
got it. Yeah,
Hmm.
but now this exploration is also left.
Yes, yes.
Okay, so whenever we come up, we still update this, even though this has still, this is
Yeah,
yet to
yeah.
be explored. Yeah?
Yes,
Okay.
yes.
So we come here and we see that this is 4 and it has two options, that it is either an AND node or either an OR node.
Yes.
Yeah?
Yes.
So this is 9 here, this is 8 here. Because
Yes.
3 plus 4, 7 plus 2 edge cost. So
Yes.
7 plus 2 is 9 and this is 7 and this is 1 here. So 7 plus 1, 8. Okay?
Yes.
So we
So now
choose
4 has
8 here.
become, yeah.
Yeah? Now when we
Yeah.
choose 8 here, do we update this again as 8?
Yes,
Yes.
yes.
And this also is propagated upwards?
Yes.
8 plus 2, 10, 11, 12. So now this becomes 12.
Yes.
Is the algorithm given here? Oh yeah, there's this thing.
Yeah.
Okay, maybe it would be a good idea to go through what this algorithm says because they ask questions around this
Hmm.
algorithm itself. Yeah.
Yeah.
So okay, let me backtrack to the start itself.
Sujay, but in that max thing, what you said now, that maximum thing should be taken for and in that algorithm, I couldn't find anything of that sort. It is
But
just for all
I
children.
remember Prof saying that.
Yeah, I remember
Oh,
saying something similar too, that it was
I
either min
missed
or
Neither
that.
max.
not
Oh, I
mentioned
missed
in
that.
the slide, but verbally I listened. Like,
Ah, thanks. I missed that thing.
Okay, so add start to G, where G is, what is G here? Add start to G, compute H start and solve start, and don't mark it as solved. So this is not solved, yes, okay? So this is a
Hmm.
start node, we are adding it to G. So it's something like this right now.
Hmm.
Yeah. So that is start, and this is not marked as false, and keep solving this until this is either marked as true or the H start is less than equal to futility, and futility is something that would be provided in the algorithm itself.
That's a very high value, na? If I'm not wrong.
Yeah, that's a threshold that we want the
Yeah.
algorithm to not exceed this cost, and
Yeah.
if it exceeds this cost, then just drop it. That okay.
Hmm.
So if this portion of the, let me copy this. So if this portion of the, uh, sorry, not this portion, but this condition is responsible for the loop termination, then that means that we have found a path. Yeah. But if this condition is responsible for the loop termination, that means that we weren't able to find a path, or it's impossible to find it given the condition. Okay. So now there's two phases. There's firstly the forward phase and then there's the propagate phase. Okay. So you trace marked paths in U to a set of unexpanded nodes. Trace marked path to set of unexpanded nodes. So, oh, wrong color. So here, is this what you are doing? So what this says, that trace marked paths in G to a set of unexpanded nodes. Select a node from U, children successors of n. Okay, we select a node from U from our traced mark path, and we pick the children or the successors of that, Now if the children is empty, so if the children is empty, then we this means that it's a leaf node. Then we make the heuristic value of that as futility. Hn as futility. Does anyone know what this means? Like, what are we doing here? Like, h is the heuristic value, right?
Yeah.
So why are we making it
It is
futility?
empty.
In the above
Because the
example,
children is empty, na? There are no children. But no children is futility क्यों
no,
होगा?
in that case, this is a leaf node that would satisfy that condition. So we are marking this value, this one's a heuristic value as futility.
Why? We are taking that value, na?
Yeah.
We are taking that value and adding the h cost and applying. I didn't understand that.
Else
Children is
check for
empty.
looping in members of children. Remove any loop members from children. Remove any looping members from children. For each s belonging to s, add s to g, compute the heuristic value, and if s is primitive, mark that as solved.
S is primitive. Primitive means that
Yeah, that's
child node, the last node.
yeah.
That
So
primitive thing. Okay.
so what does this
So
empty
children is
means?
empty बोलेगा तो क्या है?
If children is empty, and then there's the backpropagation phase that while m is not empty, remove the deepest node from m being the node that we have taken, and compute best cost for d from its children.
Oh, एक minute. Means there is no child node. Does that mean that is abruptly ending somewhere? It's not. There are no primitive nodes existing at the end. So that means it's like infinite type, na? So you cannot go ahead, kind of thing. So this is not a futility one. This is the primitive node. What you have written
Yeah,
is a
this is
primitive node.
primitive, yes.
So if there is no primitive node existing over there, then it should be considered as you should not go ahead. It's a roadblock there. So assign fidelity and then that's what I guess from this.
Okay, so the cost of this portion is 15, the cost of this portion is 11, so this becomes 11. Yeah, and
Yes,
we
yes.
pick 5 because 5 is the max one. So that's what this says as well.
Hmm.
That we start from
And
21 and we do this.
Okay.
So we are right
Yeah.
now at 5. We're
Yeah.
right now here. Yeah. Now we
Hmm.
explore 5 itself because that's the deepest node that we have.
Yes.
And we explore 5 and see that this is 2 because this is 0, this is 0, this is 1 and 1. So
Yeah,
this is
and there is
2.
one more or, but that is quite expensive, so we'll not consider that.
Yeah.
That up to
11.
10.
Oh, right. That this is 11. I forgot that.
Yeah.
Yeah. This is 11.
Yeah, even I had missed that earlier. Yeah.
So now this updates to 2. Yeah.
Yes. Yeah.
This is 2.
Got
And,
five. Got five and put two.
and yeah, this is also marked as solved here.
Yeah.
That because it had primitive children, now this is also marked as
Hmm.
solved.
Yes.
So now this
Yes.
thing is propagated upwards. That 4 plus 2
Yes.
is 6 plus 2, 8. Yeah.
Hmm.
So now
Yeah.
this has become 8 and because of that this has become 8.
Yes.
Okay. Now
Hmm.
we talk about exploring this thing.
Yeah.
Yeah, that's what we explore. Now we explore 4. So in 4 we see that there are again 2 nodes to go. One node is of cost 9, 3 plus 4 plus 2, 9, and the other is of cost 8. Yeah.
Yeah.
So we come down
Yes.
here, this one,
Hmm.
and this is marked as 8 again.
Yes.
Because
And
of
solved.
this, 8 plus 2, 10, plus 2,
Hmm.
12. So this becomes 12.
Yes.
This is
Still,
not
it is
marked as
lesser than
solved.
15. Sorry, it should not be marked. That's all because there are nodes ahead, right?
Hmm.
So
So this is 12
and
now, this is 8, and
yeah,
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 we next explore this one. So now this
yes,
7 goes to 3 places, all 3 are OR nodes. 9, 10, 11. So this is 10, this is 11, and this is 11. Yeah.
Yeah.
We
Hmm.
pick this one because that's the least cost. So now
Yes.
this becomes 9. We explore,
10, 10, 10,
oh yeah,
10,
sorry,
not
10.
10.
This becomes
Yeah.
10, and because of that, this becomes 11.
Yes.
So this becomes 11, and now this becomes
So it will,
13, 15.
so no, so or will not be considered. It will go to the and part because it's already expensive than the and one, 3, 4. That's
Right,
still
right,
9, right?
right.
And this is, yeah.
So this is 10. Now we cross this off,
Hmm.
make this 11, and
Hmm.
now this is 11. Yeah.
Yeah.
No, not
But now that
11.
11 will not be
Yeah.
considered. Yeah.
So just for now, and next we explore this one. Is that what's
Hmm.
happening? So we go to 7, and then see here, Sujay, here we are picking 3 here, not 5.
That's what I'm not understanding here. There's so many contradictions. Now here he's picking up 3.
Yeah. Kavita, I think there's a bit of construction noise that's coming from your side.
Oh, I'll just outside there's construction going on.
Okay. So here's 8, right? No, no, this was the previous value. Now the current value is, that would be picked, would become 9, because this is greater than this. Yeah. And here we should pick this one to explore, like, but here what we are doing is that we picked 3 to explore, here we picked 5 to explore.
This is the contradiction.
Mm. So let's say, no, I too remember the professor saying that we pick the maximum one. So let's just explore 4. Yeah. So if we explore 4, we get to see that here it's a primitive node. So this is a value of just 1. Yeah. So this value should become 1. And because of that, now this new value becomes 3 plus 1, 4, plus 2, 6. Yeah.
Yes, Sushant.
So now this 9 instead becomes 6, and now 6 is propagated upwards. That's 6 plus 2, 8, plus 2, 10. Okay. But if we would have taken 3 like in the example, so let's do, okay, let's take 3 for cross verification once. So if we were to take 3 as the example, so now this 3 becomes a 1, and now 1 plus 5, 4, so this thing becomes 7, and now instead of 9 we pick 7 here, so 7 plus 2, 9, 10, 11, so this drops back to 11 again. Is that what happens? Yeah, this becomes 11. Okay. So now that thing has become 11. Edge cost is 1, not 11. Yeah. So that is 11. So now we explore this thing, and we know that this cost is also 1. So if this cost is also 1, so 1 plus 1, 2, plus 2, 4. So this should become 4. 7 instead becomes a 4. So 4 plus 2, 6, plus 2, 8. So we are back to 8. Is that yeah.
Yes.
So we are back to 8.
Choosing 4 and 3 made us
I
made us
forgot this as
take
well.
one.
Yeah, we should mark this as solved, and because both of these are solved, this is now solved as well. Yeah, and now because 21 has one node that is marked entirely as solved, the start node has one child that is marked entirely as solved. We mark this as solved as well, with 8 being our final cost. Yeah, was that cool enough?
Yep.
So let's take another example, but this time the
He
edge
has
cost is,
also told that the professor has also given another example. Just he changed the age cost
edge
from
cost
1
to
to
10.
10 and
Yeah.
the solution changes.
So let's do that now. That I just take this, but I take the edge cost as 10.
Ishan, I asked ChatGPT
Yeah.
saying choose maximum cost among all children for and nodes.
For and, no?
For and nodes. And
Hmm.
or nodes choose minimum cost child. Only one child, no?
Yeah.
Or when we take go with or,
Okay.
we have only one child, so choose minimum cost child. Okay. But for
Oh,
and
I
nodes,
think it's because,
choose
no? It's
maximum
because,
cost.
yeah, it's because and may that it is the worst case scenario, no? Because we have to anyway consider all the cost.
Yeah.
So I think
Choose
for that
maximum cost
it
among
is
all
considered
children.
max. Mm.
It does not make sense saying that we should pick the minimum child of the OR node because an OR node would only have one child. Yeah.
Yes,
No,
yes,
there may
that's
be
why I'm
multiple
mentioning
or
not
nodes, no?
children, child, just child.
Yeah. Just child.
For
Yeah.
and nodes, it's mentioning among all children.
Pick the max one. Yeah. So here,
Even for all.
four should have been picked instead of three. But no matter which you pick, the answer would be the same. That's what
Yeah.
it means. Yeah. Let's try to
Sorry,
do this.
one clarification.
Yeah.
Sorry, Ishan. One clarification, Sujay. We must always, for AND node, it should be the maximum value, and for OR, it should be the
Only one value.
min-
Or
Only one
minimum
value.
value.
yes.
For
What
or it
Or
minimum
will be
value?
node,
one, no?
for or node, there will be only one value. For
Yeah,
example,
only one value. But if, for example, this node 7 and 10 that we crossed, if something like this node comes where they have three children, then which one to pick? Minimum?
yes, minimum.
Yes, minimum.
Oh, okay.
Yeah, because that's what we do at the start as well. Yeah, that we have two different coughs, 15 and 11. So we always pick the minimum one.
Sheval, just remember that we have to pick only minimum, except that if and has children, like and has say two ages, so you have to consider the maximum of that.
This is
Only
an
the
OR
exception is
node.
and.
Yeah,
Yeah,
Okay,
21
perfect.
is a or node.
OR node. So that's why we pick the minimum one. So we pick this side. Yeah. But
Yes,
whenever we have an AND node, like 4 is an AND node, so we pick the maximum one.
Yeah, okay.
Yeah. So okay, so now edge cost is 10. So now this becomes 6 plus 7, 13 plus 20. This becomes 33. And this becomes 4 plus 5, 9 plus 20, 29. Yeah.
Yeah.
So we pick this. So now this thing becomes 29.
Hmm.
And now because this is an AND node, we again pick the maximum one to solve. This one. Okay. So now this is 0, this is 0, and both of them are solved. So we mark this cost as 20. Yeah.
Yeah.
So that this is 20. So now this thing becomes 4, 20 plus 4, 24 plus
don't
20.
we check this 11? This 10 is there, no? Child of 5.
Oh right, yeah, that too, that too.
Oh
Sorry,
yeah. Yes.
I always ignore that this is also a thing. Okay, yeah, it's not in the peripheral vision. So okay, so now this thing becomes 20, yeah, and now this child is also 20.
Hmm.
So which one do we pick? Because both are 20, yeah. What have they
What
picked
is
here?
there in the lecture?
Uh,
We have to actually open the lecture, not over here.
so for 29 to let's see, 29, 30,
Achha,
They
they
chose
have given
and
that.
node.
Okay.
They chose and node.
and for what reason? Because both of them are cost 20, yeah. This one's discussed in which one? Not algorithm, graph plan. Solving this.
Here's for example. Here's for example, where
E is one choice, and
Okay,
F
A of star
not
is
over
one.
here.
two
Yeah,
costs.
This.
yeah, yeah.
Fill the
Okay,
best
this
solution.
one.
And if this partial cost is its values are likely to overestimate the values of the actual solution. And we will also see that when you overestimate, you tend to terminate faster. Just like when W A star, we saw if you have a high value of W, it tends to terminate faster than A star, but it doesn't guarantee you the optimal solution. So assume every Arc has a node vector choice, and it say this node 7 as following from that the cost of 9 here, the cost of that
Let's
8
see
and
whether
not
he
still appears to be
mentions-
the better, so it still remains here, even though the cost has gone up from 8 to 12. So it started at 21, went down to 11, went down to 8, and now suddenly it has gone up to 12. And why is that? Because this node, which had a cost of 4, has gone up by 4 to this one has gone up from 4 to 8 essentially. So the overall cost of that solution has gone up, but it is still the better option. So we define, let's say this node 7 as seen here. Let's see. Which was this node 7? This node 7 was this one here. We have defined that, and we have found that there are 3 ways of solving that, and their costs are respectively 9, 10, and 10, of which 9 is obviously the best choice. So its cost has gone up from 7 to 10, as you see. And because of that, the fact that its cost has gone up, this arrow has shifted from the right choice to the left choice. Why? Because the cost of that left choice we had seen earlier was 3 plus 4, 7 plus 1 plus 1, 9. So that becomes a better choice. So you can see that at any given stage, the best path is marked. From the root, you go here. From this node, you go here. At some point, if you were to shift back to this, then from this node, you would go here. So wherever a node has been defined, the best choice is always marked, whether or not it is part of the prospective solution or not. So now we have this node with 3 and 4. One of them we have to define. Let's say that we choose to define this node 3, which is this node
Okay, he did not mention why we defined node.
graph, as you can see, which are 21 for this and lower values for that, are likely to be underestimates, because at least 10, 3, 4, 5, 7 cost of the estimated cost of the solution has gone up essentially, which is typically the case when you underestimate cost. And if you remember the A-star algorithm, as we went closer to the goal, the F values were actually increasing essentially, and especially in the case when the heuristic function satisfied the monotone condition or the consistency condition, they were provenly known to increase essentially as you go closer to the goal. So again, let's choose to define the same node with the heuristic value 5. And this time what happens, once we define that node with a value 5, the last time we did that,
Oh, he
this is
did.
the cost
I
0
think
and this is the cost 0.
the
That we have set for
cost
all leaf nodes.
became
Last time
higher.
this was
That's
1
why
and this was also 1.
he
So
went
this
to the
5
left
actually went
side.
down from 5 to 2. But this time, these costs are 10.
We
So
didn't
it has
check
gone
the
from 5
cost
to
over
20.
there, no? We
And
checked.
which is why
I don't
this
remember.
right branch has suddenly started looking more expensive. So what is the cost of the right branch? It's 4 plus 20, which is
Okay. So now this becomes 20, and because of that, we still mark this as 20. Yeah, that there is surely this left to explore. So because of that, it becomes 20 plus 4. No, doesn't it become 44? Why is it 33 there?
Well, because no 20 plus 10, 30, and oh yeah, over here also there is something, no?
Let's
24.
see.
But this value 5,
30
the last time
plus
we did
20.
that, see this is the cost 0 and this is the cost 0 that we have set for all leaf nodes. Last time this was 1 and this was also 1. So this 5 actually went down from 5 to 2.
20.
But this time, these costs are 10.
Actually,
So it has gone
it
from
should
5
be
to 20.
above 40.
And which is why this right branch has suddenly started looking more expensive. So what is the
Yeah,
cost
it's
of the right
above
branch?
40. That's why
It's 4
he
plus
went
20,
to
which is
went and updated over there, no?
24 plus
That is
20 because of
33.
this 10 and this 10. And so this will be 24 plus 20, which is 44. Whereas the left branch is 6 plus 7
is higher
13 plus 20
than
is
the
33.
33 over there. 6 plus 7
we
plus
still
20.
consider. Okay, yeah, that's what you meant.
Yeah.
So we still.
Irrespective whether or and is becoming 44, right?
This becomes 44, and now we make this 33 because that's the smaller one. Yeah, okay. Now
The left one, yeah.
okay. So now we check for this one. That okay, this is 33, and we pick the maximum one here.
Yeah.
That we are picking this one. Which one is picked
Yes.
in the lectures? They explore.
Yeah, 7 only they are
7
exploring,
only,
right?
yeah. So if we explore 7, what we get is that there's just only this one option, and that's an AND node. Like 7 is an AND node. So now this becomes
Yeah.
3 plus 4, 7 plus 20. This becomes 27.
Yes.
Yeah. Now because this became 27, this is 6, so that is 33 plus 20,
Plus
that is
10.
53.
20, yeah. 53.
Yeah.
Yeah.
So now that is 53, so that's why we pick the right branch because that's a smaller one. So
Yes.
now we update that back to 44. No, not back to 44, to 44. Yeah. But now this thing remains that okay, for 5 we did not even finish the exploration. That we are getting 20 from both sides. That this is 20, this is 20.
That will go out anyway out of here because it is going ahead now. There is no primitive node over there. So again, the
he
each
did
cost.
some mistake there that while exploring 5, he only explored this portion, not this portion.
Yeah, but Ishan, even if he had explored that, it would have been no use.
Yeah,
He would
yeah.
have considered primitive
Yeah,
over there only. Yeah.
because both are of the same
Yeah, immediately after 5 they are primitive nodes, right? Here you are going to 10 and again then you are going to primitive. So that 20 edge cost will get added additionally.
Yeah. And this is also marked as solved because its children are solved.
Yeah.
Yeah, I forgot to do it. Okay, let's do that sequentially again properly this time. So now we start off with this being 33, this being 29. So we pick 29 because that's
Mm.
a smaller one. We move on here because this is an AND node. Yeah,
Mm.
and we see that okay, the 5, this node is the maximum one. So we explore this. And we explore this, so we get the cost of 20 from this and the cost of 20 from this.
Yes.
From this child, this means that this is cost 20, and this child too, this means it is cost 20. But here it is
Yes.
solved as well. So that's why we mark this
Yeah.
as solved. We update this cost to 20 plus 4, 24 plus 20, 44.
Mm.
And here we compare that, okay, no, 33 is a lot smaller than 44. So we should pick 33 as our next cost. That
Yes.
we are
Yeah.
exploring this portion now. So here we
Yeah.
again pick 7 being the larger subnode of this max node. And we
Yeah.
see that 7 is also, and sorry, we pick 7 because it is the largest subnode of this AND node, and 7
Yeah.
itself is an AND node, which leads to 3 and 4. So 7's cost is 27.
Yeah.
33 plus 4, 7 plus 20, 27. So because of this, the
Yeah.
new cost becomes 6 plus 27, 33 plus 20, 53. And now 44 is the smaller one, so we switch back to the to the right branch. Yeah.
Yes. Yeah.
So now, because 5 is already marked as solved because it already had these children,
Yeah. We go to
we
4 now.
explore this because that is already solved.
Yeah.
So now we
Yes.
explore this 4 branch and we see that it has these AND nodes and it has this path as well.
Hmm.
Okay, so 4 is not an AND node, yeah?
4 is an OR node.
4 is
an
OR node,
OR
no?
node, yes. 4 is an OR node, which has 2 paths. That either it lead to these 2 paths or this path. Okay?
4 is actually part of AND node, that 4 5 wala AND node, but
Yeah.
now that is the only one which is remaining.
Yeah.
5 is already solved.
By itself, it is an OR node. Okay? And we see that this path is 27 because again 3 plus 4 plus 10 plus 10, 27, and we see that this is 17.
Yes.
So we make this 17 for now.
Yeah.
Yeah, this is also 20 by the way. So we make this 17, and because of this, now this cost becomes 17 plus 20, that is 37 plus 50, 57. So this becomes 57, and we switch back to this. Do we?
Yes.
Yeah, 57. Okay. So 53, and we again get 27 here. So we switch back to that.
Yeah.
Yeah, and yeah, let me keep track of the path as well. That this is the path, and here we took this path. Here we have taken this path. Okay.
Yeah.
So now we are at 23 here. This has been explored.
6th one has to be explored, no? 6.
We don't
7 का
explore
हो गया,
this.
6 का नहीं, I think the next level is बाकी है ना 6 का. 7 का next level we have done, 6 का we haven't done ना.
No, but these can be solved as well, right?
Right, but that is one level ahead na. Just check in the lecture what they are doing.
So we mark
After that?
7. And then, yeah, so I think they are updating this as well. This itself.
This one only?
Yeah. That we firstly pick this one because this is an AND node. Yeah.
Hmm.
Because this is an AND node, we pick this one and we see that it leads to a primitive node. So its cost is just 10. Yeah.
Okay.
So we update this cost. These are also primitive. Let me just make that more clear that way. So now this is also a primitive node. Now this has been solved. Not this is not primitive. This has been solved. So now this cost updates to 10.
I'm having one query here.
Yeah.
I'm having a query. The moment the way we did five for five and then four, because after five we did four, right? Because that's a part of that and. Why didn't they do it after six, seven? They didn't do six because there's a part of that and.
No,
How
wait.
will we
What we
understand?
did was that we solved the children of 5 first. And now we know that the children of 5 are already solved. 5 is already marked as solved. So we do not need to go further down this. Because this has already been solved. That's why we moved on to 4. But here neither are solved, I think.
Okay, okay.
So that's why we
Okay.
go further down this, because even in the algorithm it is mentioned that you pick the deeper node first.
Okay,
That
okay,
remove
okay.
the deepest node from M.
Oh,
And the
oh,
deepest
I see.
node
Okay,
is these two.
okay, okay.
So now we
Fine.
solve this as 10. So now the cost becomes 3 plus 10, 13 plus 20, 33. Yeah. So this becomes 33.
Uh,
This cost becomes, so 6 plus 33, 39 plus 20, 59.
no, how did you make it 33? 1 minute.
33
How
because
did you make it
3
30?
plus 10, 13 plus the edge cost.
Okay, 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 fine.
Yeah. 3 plus 10, 13 plus 10 plus 10. So 13 plus 20, 33. Now
Okay,
because this is updated to 33, this is 6. 6 plus 33, 39 plus the edge cost 20. This becomes 59. So we move back to again the right one.
okay.
Now this thing becomes, sorry, this became 53 momentarily, and now this became 57. Yeah.
Hmm.
And now this has become 59.
Okay.
Yeah, okay. So now this is 59. Uh, no, wait, this is 57. Yeah. Damn, this is confusing. Yeah, this should be 57 now, not 59, because we are picking this one. And now here what we have here
Right.
is that our deepest node is this one in this
Hmm.
path. This is the deeper node. And so this is 3 plus,
Or no.
no, I'm wondering why do we not consider this again? Because this,
27, higher value.
yeah, but the updated cost is 3 plus 10, the updated cost is 33 now. This is updated to 33 because we explored this. So do we not compare here?
What is
Three is the better
nature?
option. So you can see that the arrow has, the marker has shifted. It's saying, no, this looks too expensive. Let's go to the other side. And this is also a characteristic of underestimating functions, that this thing that was somewhere you might get a better option, which is a better choice, and it shifts its attention there. So we define this 7 now, and let us say, so this was what was 7 here. So that's a node that we defined. And let us say that it has an AND choice below it with a cost of 3 plus 4, which is 7, plus 10 plus 10. So that makes it 27, which means this has become 27. Its sibling is 6, which is 33. So this has become 53 because of this extra 10s that are also sitting there essentially. So again, you see that the best marker is shifted to the right hand side, because now suddenly that appears better, and we go and define this part, the node 4. So remember that this is the node we are defining next, and that was the node that we just defined, and it has one child. It has two options. One is this all choice leading to a node with cost 7, which is why its estimated cost is 17. So 7 plus 10 is 17. If it had chosen the left choice, which had also 3 plus 4, which was 7, but it had two edges, so that would have been 7 plus 20, which would have been 27. So this is marked as a better choice, and its cost now has gone up to 57, but it is still the better of the two nodes essentially. So remember that the left choice, so this was 27 plus 6 is 53. One sec, have I made an error here? 53, it was 53. So it should actually shift to this side, but I believe that is a small exercise for you to over there. So because this is 53, this arrow actually should be here. So you should go and find one of these other nodes essentially. But anyway, if you pardon that particular error, let's assume that this 57 is a better choice. We want to see how the algorithm will proceed from here.
Yeah, this 57 would not occur. That's why I did not write that as well. That this won't occur up until much later. that the 57 won't be occurring from this side, it will be occurring from this side.
We
That
came
firstly 53 would occur, then 57 would occur, I think.
and we defined this node with a value 7, and its value has gone up to 19. Why is that? Because the best choice below that is 9 plus 10 is here, that's 19. So that's 19, so this would be 29, which means this 27 has become the best choice. But when you look at 27 plus 20, which is 47 plus 20 would be 67, and which is not the best choice. So this 53 that we had computed, it switches back to that. In practice, if I had not made that error of counting this as 57, it would have continued with the 53.
No, this is 59.
Anyway, so now it's back to
bro. Okay.
53, and it follows this choice. There's only one choice below that, so it has to follow that. And between these two nodes, let's say it picks this node 4 for refinement. So it has defined that node. So anyway, it switches back to that. In practice, if I had not made that error of counting this as 57, it would have continued with the 53. Anyway, so now it's back to 53, and it follows this choice. There's only one choice below that, so it has to follow that. And between these two nodes, let's say it picks this node 4 for refinement. So it has defined that node 4. So this was the node it has picked for refinement.
Okay, so here 7 is picked for refinement because the cost on the left hand side is 33 now and the cost on the right hand side is 17. So it always compares. I think we need to start again for the sake of clarity, and maybe a better method would be to draw a tree by ourselves.
Meaning?
Let me show that. Okay, so let's start with this here, that this is 21. We have two AND nodes here, this being a 6, this being a 7, yeah, this being a 4, this being a 5. Okay, so here we know that the cost is 6 plus 7, 13 plus 20, 33, and here the cost is 4 plus 5, 9 plus 20, 29. Yeah, so the cost of the start node would update to the weight of the minimum one of its of the children with the minimal cost. So here 29 is smaller than 33, so that's why this updates to 29, and we go down this path. Yeah, now here, because this portion is an AND node, we pick the node with the maximum value. So we pick 5 here and we explore that. Okay, so upon exploring 5, we see that there's a node down there with a cost 10, and there are two primitive nodes here as an AND node. That no, I'll draw this properly as red square, and there are primitive nodes here. Okay, so both of the costs are 20. That from this side too it's getting cost 20, from this side too it is getting cost 20. So it would pick this one, and it would pick this one because it is being solved a lot quicker here and get marked as solved itself. Okay, so far this is the path. Now because this cost has updated, this 5 would instead become 20. Then now this is 20. I don't need this here. Okay, so the cost would now update to 4 plus 20, that is 24 plus 22, so this would become 44. Yeah, now because this is 44, we come back to this node. Okay, we did our forward pass this way. Now after we marked this node as solved and we got its weight, we again do a backward pass up to the start, and now this deliberates over what to pick, whether to pick 33 or whether to pick 44. Because this is an AND node, it will pick a smaller one. Sorry, because this is an OR node, it would pick a smaller node. It would pick the smaller weight, so that's why this weight upgrades to 33. Okay, so now we come to this portion. So now what happens here is that 7 is our node with the max value, so we explore 7, and exploring 7 points us to these 3, that there's, sorry, these 2, that there's a 3 here and then there's a 4 here. It points to these 2, and this is an AND node, and through this it knows that the cost here is 3 plus 4, 20, plus these 2 edge costs, so this cost is 27 here, so its weight updates to 27. Yeah, that this itself becomes 27, and the new cost becomes 6 plus 27, 33 plus 20. So the new cost here becomes 53 instead of 33. And now we are back to the start node, we are back here, and now this start node again deliberates that okay, the left path is of cost 53, the right path is of cost 54, so it again picks the smaller one, being 44 here, not 54, 44. So now this time we are exploring this portion. Now in this portion we have already marked this node as solved, so this path is confirmed. This,
I have one question. When you say this node is solved, all its children should be solved for it to be solved, right?
yeah, oh sorry, this is an AND node by the way. Yeah, so
So
no,
still not solved, no?
no, only one child needs to be solved, I think. That either this portion should be solved or either this portion should be solved. That happens for the start node as well, that if this entire portion is marked as solved, then we mark this as solved as well, not caring about what the state of the left portion is. Yeah, that's what we
Okay.
did
So
here
any
as
one
well.
child should be solved.
Yeah, because that's what we did here as well, that even though this is still unsolved, because these 2 were marked as solved, we marked this as solved, that yeah, no, we have
Okay.
already explored everything. So it's just that one child needs to be solved. So I'm marking the paths this way, that this path leads here and this path leads here. Okay, so now because this has already been marked as solved, we don't need to explore that, we need to explore this, and that is 4, and this 2 leads to these 2 things, this and this. Yeah, what was the professor meaning in the lecture when he said that he made a mistake? Yeah, it should have been 53, so he was talking about this, that this cost should have been not 57, it should have been 53. Okay, so what we do here is that now this 4, this node that we are talking about, I should make the arrow here, that this thing that we are talking about, that this thing that we are talking about leads to 2 different nodes of cost 3 and cost 4. So here to the cost becomes 3 plus 4, 7, and this becomes 27. So this cost should update to 27. Yeah, that this is 27 now, and it leads to these 2. Okay, and now the new cost becomes 27 plus 20, that is 47, plus 20, 67. So the new cost of the right hand side becomes 67, and we are back to the start node. Now the start node would again deliberate that okay, the left hand side costs 53, the right hand side costs 67, so which one should I pick? And it would pick the lesser one, being 53. Okay, so we are back to this portion because we have explored this much to the depth. Yeah, and from here we again pick the maximum one, being 4, because this is an AND node, and we explore 4, and that leads us to a primitive node, this node. I'll draw this again as red. So this becomes a primitive node, so this leads to a primitive node. Because of that, the cost of 4 now changes to that is just 10. Yeah, that earlier it was 4, now it is 10, because that's the only thing that is leading to And because this is solved, this should be marked as solved again. And because this is being marked as solved, the weights of its parents would also update, both of them. So wait, yeah, this has been marked as solved. So now this would change to 3 plus 10, that is 13, plus 20, 33. So this changes to 33, and 33 plus 6, 39, plus 20, 59. So that's why this thing becomes 59. And now this again deliberates which one to pick, and it sees that 59 is still the lesser one, so it would now go on exploring this path. Are you able to follow so far?
Yes.
Yeah. So
Yes.
now it explores this thing here. I should remove this. I should have removed this arrow back then. So now it is exploring this thing, and this again leads to this primitive node. Yeah. So because this leads to a primitive node, now even this weight changes to even this node becomes marked as solved, and its weight also changes to 10. So now the new cost for this AND node ends up becoming 10 plus 10, 20, and 20 plus 20, 40. So this becomes 40. Yeah. And because for this node both of its children are marked as solved, even this becomes marked as solved. So that this is the final weight. Now this won't change from 40. Now it is fixed as 40. Okay. So now this has become 40. So 40 plus 6 is 46 plus 20 again. So 46 plus 20 is 66. So now this weight becomes 66, and this would still continue to explore the left hand side. Is that what happens? Yeah, that is what happens. That we still explore this one. So this 53 updates to 66 because that is the lower one, and we explore this thing now because that is the one that we consider deep, the deepest. Okay, so now we are here, we are exploring this, and we see that this leads to two different paths. That here it leads to either an AND node, this one, or it leads to an OR node that is way far down there, but it's a primitive node. Okay, so it's a primitive node here. Okay, no, I think I mess up the terminology a lot. This is itself an OR node. It would either lead to this AND node, or either it would lead to this primitive node. So the cost from the left hand side is 6 plus 8, 14, plus 20, 44. No, 6 plus 8, 14, plus 20, 34. And cost from the right hand side is 10. Yeah, so it would pick this one, becomes solved by itself, that now even this thing is solved, update its cost to 10 because that's the lesser one. Yeah, and now we again update the costs. So 10 plus 40, 10 plus 40 is 50, 50 plus 20, so this is 70. So we get 70 here, and okay, so now what happens? Because these two are marked as solved, so this should also become marked as solved, and no more exploration should be done. So does this become marked as solved and with the cost
No,
70?
it should not take 70, na? It should take 67 in that case, no? Or no?
Right. So only when the cost this hand side becomes less than this, only then this should be marked as solved, right?
That's what I think, yeah.
Yeah.
No. Actually,
No?
this 66 is a OR node. Okay.
Earlier the
One
cost
of
was
the
66
chain-
here. Yeah.
Okay. Now you can make it 70. It's already 10
Now
and 40
updating it to
solved.
70, yes.
Yeah. Now that start node is a OR node. So left child is solved. One child is solved. So it will solve and finish.
It will solve and end there.
Yes, 70 is the answer.
It won't try to solve this.
It will
No,
not pick up
because
67 thing.
Okay, let's just watch the lecture.
It's 9 plus 10 is here, that's 19. So that's 19. So this would be 29, which means this 27 is become
first
the best
solve is
choice.
solved
But
out.
when you look at
So
27
there-
plus 20, which is
whatever is
47 plus
first
20 would be
solved.
67, and which is not the best choice. So this 53 that we had computed, it switches back to that. In practice, if I had not made that error of counting this as 57, it would have continued with the 53. Anyway, so now it's back to 53, and it follows this choice. There's only one choice below that, so it has to follow that. And between these two nodes, let's say it picks this node 4 for refinement. So it has defined that node 4. So this was the node it has picked for refinement. And it has one child, let us say, which is the cost 0. And so from 4, this has gone up to 10, basically. It was 4 before this, it's gone up to 10. So this is 10 plus 3, 13, plus 20 is 33, and 33 and 6 is 39, plus 20 is 59. So this still remains the best choice here. And then this is the node that we are refining next, basically. So let's say that node also has the same child, which is this one here. And because it has a cost 0, the leaf node has a cost 0, but this cost goes up from 3 to 10. And so now it is 20 plus 20, which is 40. 40 and 6 is 66. And it is marked as the best choice. So what was the other side? The other choice was, as you can see, 67, which is still a little higher than the 66. So 66 is marked as the best choice. And so we follow the marked choices. All this part of the solution is solved. So there's nothing more needs to be done. Only this part needs to be defined. So this is what it does next. So the thing that you would notice that when it is underestimating, it is oscillating between different options, and it's saying, oh, maybe that's a better option, maybe that's a better option. That's because each of them are being underestimated, as opposed to overestimating, which once it takes, now it has got some options here. One is an AND OR with a value of 6 plus 8, which is 14 plus 20 would be 34. But this is a simpler choice. It has a cost of 0, and therefore its cost has gone up a little bit. It was 6 to start with. It's come down to gone up by a little bit by 10. But because it's gone up to 10, so 10 plus 40 is 50, so this has gone up to 70. The other choice from this side was 69, and therefore the arrow has switched back to the right hand option, which means it will follow the path.
It won't mark it as solved. It will explore the right hand side. It will explore this, but our cost is 67. He says the cost here is 69. Did I make some mistake? I think I did. Yes, I think I did. I did not even explore this down there. That this path, there is also this path, yeah. Let me just make this like this path directly.
There's
to-
one or over there. Oh,
Yeah, there's this one or that I missed, I think. I don't think it would have any repercussions, but that's something I missed. That this leads to a 7 here. Yeah. So the
yeah,
cost
right.
from this, it's 17, so this 17, so it still explores this, and the cost from this ends up becoming, this is 10, and the cost from this is, here it is 9, so 9 is again picked from here because it's the least cost one, so the cost here becomes
10.
no, 19.
Sorry,
19.
Oh yeah,
Now
19.
This becomes
Yeah.
29. Yeah,
Hmm.
this becomes 29. We do not pick the left hand side because the
Yes.
left hand side cost is
Perfect.
40. So we are
Yeah, yeah.
exploring this thing. Okay.
49 plus 20.
So 29, 49 plus 20, that is 69. Yes.
Yes.
69. So
Hmm.
we pick the lesser one, 69,
Hmm.
and move on ahead with it. And this is
Yeah.
69. Okay. So now we
Hmm.
explore this boy. That this 9 now leads to the same primitive node.
Primitive node,
Yeah. So its cost again just rises by 1. It itself becomes solved. So this also becomes 10.
No, it will become 90. Sorry. No, it will become 10. Na? H cost is 10, right?
Yeah, that's why 10.
So,
this
oh, sorry.
becomes
10.
10.
Yeah. Sorry.
Yeah. Now because
Wait,
this is 10, this would
Yeah.
end up becoming 20.
Yes.
And it would also be marked as solved.
Yeah.
Now because this is 20, this would end up become 30.
30.
And this
Yes.
would also be marked as solved.
Yeah. 30 plus 20 is 50,
And
70.
now even this is 70. So which one to choose?
But the algorithm says follow the path, follow the markers, and it takes you to only one node that is left. So you go and refine that, and when we refine that node, we get so this is a node that we are refining, and it takes you to a node with cost 0. So it was 9, it's gone up by 1 to 10,
Right
and
one.
it has become solved. So all this solved label keeps propagating upwards. As you can see, this is solved, this is solved, this is also solved, and therefore the root is labeled solved with a cost of 70.
But
The
that
important
is
point,
not the only path, yeah? Because sure, this
Exactly.
becomes 70 and this is marked default, but there are different paths that are available. Like for
Exactly.
example, I can take this path. Yeah, that's also a path of cost 70. I can take this path. That's also a cost.
This is 70.
Yeah, this is
That
also
one was not
70.
70, na?
No, that's also
That one
70.
was not 70, the earlier one. Earlier
Okay,
one,
no,
how
yeah, that's not
can that
70,
be?
that's 80. Yeah, okay, this is
That's much
70.
higher, huh?
Yeah, that's
Yeah.
80. This is 70. So this path
Yeah.
was this is one possible path.
Hmm.
Okay, this is the one possible path. The other possible path is this one.
Yes. On what basis they selected the right one?
So this is also another path. Is this also 70? Because then 40
I
here
think
is
so.
correct. 40 here is correct. Yeah. This also 10 here is correct. 40 plus 10. Yeah, this is also another path. So two paths are possible.
So is it that they found it last and there is no more path and it's not better than the other one? That's why they selected that.
Yeah, I think. So two paths are possible, both of the same cost.
I think we have to use tiebreaker ka thing, I think then maybe.
is that underestimation forces an algorithm to explore all options
No, but that
before
is only for the
terminating. And by the time it has finished exploring all,
nodes,
we will
I
take a
mean
quick look
edges,
at
right?
so
Not
this is
for the entire path.
back. We will
Okay, let's just take up another example.
From PYQ or
No, from the
DAP?
assignment. Yeah, yeah. Let's just take up graph plan first. Then we can take up the other one. A star. Yeah. Okay. For 1.5 hours, just discussing AO star and graph plan, and didn't even solve any questions. Okay. So this is the question that's given, and this is the yeah. So this is, what do we call this again? What is this? I forgot. This is just a graph plan layer, right?
I don't know what it's called actually.
No, this is the graph plan algorithm itself, and this is just the first two layers of the graph plan, a tree. That's it. Because I think the graph plan data structure is a completely new data structure, and it's not a tree or anything. Okay, so this is PA graph plan,
This is called yeah, planning graph.
planning graph. Yeah, okay. Because this is not a tree. Okay. So the question basically asks which of the following are mutex action pairs in layer 1. In layer 1. This is layer 1. This thing. this thing is layer 1. So we need to find mutex action pairs in this layer. Yeah. So again, how do we say that something is mutex? It is based upon these three conditions. I delete this. I think maybe I should solve it here itself. No need for a separate page. Yeah. Okay, so on what basis do we say that actions are mutex? So these are the four conditions. That whether when two actions have conditions such that they are pairwise mutex, when two actions have a precondition, if any precondition as a positive effect of an action and a negative effect of another action, that's inconsistent effects. There's the interference condition if an action needs a precondition while it is being while the precondition is being destroyed by another action. The precondition is being destroyed by another action, and the fourth one is that if a precondition is just being consumed by an action. Okay, so first option is no op 3 and unstack VE are these two mutex. So no op 3 and unstack VE.
I think yes, because
Yeah.
arm empty
Because of
to
arm empty.
both.
Yeah, because arm
Arm
empty is a positive effect of both actions and a precondition to both as well. No, it's not a positive effect. Wait. Based on what condition is it? Are these two actions mutex? So let's just check. That is arm empty. Is there any precondition of action A and B such that the preconditions themselves are mutex, right? We are dealing with the first layer, so the first layer will not have any preconditions that are mutex, right? Because the algorithm is just starting out. This is just the starting state, so there wouldn't be any mutex preconditions. So the first condition will not apply here. The second condition, inconsistent effects, this one says that if there is a precondition that is in a positive effect of an action A and a negative effect of another action. Okay, so arm empty is a positive effect of no op 3. Yeah, while arm empty is a negative effect of unstack BE. That unstack BE is consuming this while no op 3 is trying to add this. So both can't happen at the same time. That's why unstack BE and no op 3 are mutex based upon the first condition, based upon the second condition.
Second condition.
Yeah, so no op 3 unstack BE are mutex because the first reason is inconsistent effects, arm empty. Arm empty. Let's
Now,
just check
to
the
pause.
other two conditions as well. The second condition is interference, which says that if an action needs a precondition while the precondition is being destroyed by another action. So no, I think here interference does not happen because this is not being destroyed by anything, right? proposition P such that it is a precondition of an action A and a negative effect of action B. Precondition of action A and negative effect of action B. Does that is that valid? Oh, I think I lost the slides. Let me just see the mutex conditions again, because I think that should be considered valid there, that this condition applies. Yeah, here. So interference, there exists a preposition P such that it is a precondition of A and a negative effect of B, and vice versa, or vice versa. So I'll say that arm empty is a precondition of no op and a negative effect of unstack BE. Yeah? Does that
This
make
is also satisfied. In interference also one region, one of the region.
interference? I don't get the intuition for interference though, arm empty. Because I understand inconsistent effects, that yes, the two opposite things can't be happening at the same time, that I can't be multiplying and dividing the same thing together. So what inconsistent effect basically means that something can't such a situation or such a circumstance can't happen where a thing exists and doesn't exist at the same time. So I get inconsistent effects. But what does interference mean? That if something is a precondition of an action and a negative effect of another action, so it can't
I
happen.
can give one intuition.
The intuition
no
that I
of
understand would be when we are talking about previous layer and the next layer. That's the only thing I can think of. What were you saying?
telling that only.
But mutex actions belong to the same layer, right? It can't be that one action belongs here, one action belongs to the next layer.
Yeah, that won't happen within the layer.
Yeah, within
All
the
mutex thing is within the layer. Action layer or preposition layer. Proposition.
What does this say? There exists a preposition such that P belongs to precondition A and P belongs to negative effects of B or vice versa. Then only one linear ordering of the two actions would be feasible. Okay, then only one linear ordering would be feasible. Okay, yeah, then these two are correct. Yeah, then these two are mutex based upon the interference condition, because we can only say that firstly no op occurs, then unstack BE occurs, right? They can't occur together, or it can't be that unstack BE happens before no op. That can't happen. Yeah?
Correct.
So that's, I think, what it means. And then the final condition says that if P is a precondition and a negative effect of an action A, no, it just means that if a preposition is being consumed by an action and it can be consumed by another action, then these two actions are the same. Yeah? So based upon that, NoOp3 and unstack BE are not mutex, because arm empty is not a negative effect of NoOp3.
Yes.
It is not being consumed by that. Arm empty is being consumed by unstack BE, but it's not being consumed by NoOp3. So that's why only based upon these two conditions it is mutex. So this. Next is no op 3 and pickup C. No op 3 and pickup C. So I believe again because of these same conditions, these two should also be mutex. Yeah? Because of the same conditions here. Because
Yes.
inconsistent effects, firstly because no op 3 is adding arm empty to the second layer while pickup C is removing arm empty from the second layer. That can't happen, and then there's also interference that only one linear ordering of these two is possible. Okay, so this as well. Unstack BE and pickup C. Unstack BE and pickup C. Okay, let's just again look at arm empty because that's the only common one between them. Yeah. So they both are again looking at this, and here what I can say is that firstly again the first condition, competing needs, will not happen here because all the prepositions in this layer are non-mutex. So we don't need to check the first condition, competing needs. We only need to check inconsistent effects, interference, and the fourth condition. So yeah, so these two are mutex because of the fourth condition, because both of them are going to consume arm empty. Yeah.
Yes.
Unstack BE and pick up.
Both consuming, both deleting.
Yeah, because arm empty belongs to precondition of unstack and negative effect. I should write this properly. Because of unstack, I'm just using un for that, and arm empty belongs to the positive effect, negative effects of unstack. And at the same time, this is happening for pickup as well, that it belongs to the same preconditions and negative effects of pickup as well. Pickup. Okay, so based upon the fourth condition. And is there any other reason? Interference happens here as well, I think, because arm empty is a precondition of unstack and a negative effect of PC, right? Arm empty is a precondition of unstack and a negative effect of BC, and I can say the other way around, that it is a precondition of pickup C and a negative effect of unstack BE. So based upon the third condition too, it is possible. And the inconsistent effects is not true here because it's not that because no positive effect of unstack BE is a negative effect of unstack C. Yeah. So based upon those two conditions, this is also a mutex pair, and a no op 7 and pickup C. No op 7 and pickup C. Okay. So let's see. So again, inconsistent effects here, if we check that, then is there any precondition that is, so there is a precondition clear C of no op 7, which is also an added effect of no op 7, but this added effect is not being affected by pickup C. So second condition, inconsistent effects, does not apply. For interference, there is no positive effect or negative, for interference, there is no precondition of pickup C or no op 7 that is being deleted. Yeah. So there is this clear C precondition that is common for both pickup C and no op 7, but that clear C is not a negative effect anywhere. So even interference does not play here, and both of them do not share any same negative effect as well. So yeah, so both of them do not share any negative effect, so these two are not mutex. So only these three.
Guys, एक चीज मतलब मुझे बताइए, is no op, whatever is no op, so that the left side of the no op is the precondition of what, and the right side is the effect of that. Is it
No
that way?
op is
Positive,
just an
positive.
action that does nothing. So the
But then how do you
Consider-
decide? Okay,
You can
that's the
consider it
precondition.
as a positive effect.
yeah, this is a positive effect. It is adding that. Yeah.
Positive effect. Okay, and clear C, the left side is the precondition, right?
Yes.
Yes. And
Okay.
red color are red lines are negative effect.
Negative effects. Yes.
Okay, fine. Okay,
So
thanks.
that's true. Yeah. So which of the following are mutex propositions? Mutex proposition pairs in layer 1. Now we are talking about this is layer 1. Yeah. Okay, that is layer 1. So now we are talking about action, we are talking about preposition pairs. So only one condition is there for prepositions, right? And that is this one.
Next one.
Two propositions are mutex if all combinations of actions, no, okay, so all combination of actions that cause these prepositions are mutex. Okay, so now we firstly check for clear E and holding C. Clear E and holding C. Let me copy and paste this again for the second question.
We might use
In
the
this, yes, Sujay.
we might use the answer of the first question to solve.
Yeah,
In this, which one can be considered as layer 2?
no, this is 0, this is 1.
And layer 2?
Layer 2 would be the one that would happen after this.
Okay,
The
okay.
center one is action layer.
This entire thing is part of layer 1.
Okay,
Action one, P1. Right.
Yeah.
okay.
Okay, next thing. So clear E and holding C. Clear E, holding C. These two. Yeah. Let's say that we are talking about clear E and holding C. Okay. So what we need to do is that we need to check all conditions that have these as positive effects. Yes. Sorry, all actions
All
that
actions.
have these as positive effects, and check whether these actions are pairwise mutex or not.
Only one pair is there.
Only, yeah, this, no. Have we checked this?
That is not required, no. For clear E and holding C,
Yeah, so for clear E, only this is the positive effect one for clear E,
yes.
and for holding C, only this is the positive effect one.
Yeah,
So
we
there
can
is
create
only
pair
one pair.
only one.
Yeah. So the only pair is this. So this is the only pair, action pair that we have, right? And we know that this is mutex because we calculated
From
it
the
earlier.
previous question.
Yeah. So we can say that this is mutex. Okay. For the second option, we have clear B and holding C. So holding C again has this as the only action, and clear B has only no op.
No.
Yeah. So now we need to check for this whether no op 5 and pickup C are mutex actions, and I don't think they are because they don't even share a similar precondition or any of the effects. Yeah, because for both of these actions there is no precondition that is common and there is no positive or negative effect that is common, so these would definitely be not mutex. Correct? Because earlier what I was doing that is for comparing these two I was looking at what precondition is common for them both, and I know that for these two this arm empty condition is precondition is common, and based upon that I was able to check whether inconsistent effects, competing needs or interference for the fourth condition, either of these conditions were satisfying. But for NOOP 5 and pickup C there is no common precondition, right? And there is no common effect as well, so this is not mutex, and because this pair of actions is not mutex, these two preconditions are these two prepositions are also not mutex, so this that can't be true. The third one is clear D holding C. Okay, now clear D is added through NOOP 1 because that's the only action that has clear D as a positive effect, and holding C is a positive effect of again pickup C. So again this can't be mutex because these two don't share any common precondition or any common positive or negative effect. Yeah. The fourth one is holding B holding C. So now we need to check for these two. So
Unstack B, pick up C.
so holding B has unstack BE as an action, and holding C is unstack C. Yeah. So we
Correct.
now again have unstack BE
And pick up C,
and
only
pick
one
up
pair.
C, and there's only one pair that's allowed. That's possible.
And
Yeah.
these two are
These two are already mutex, so even this is also mutex. Let's just check that this is the only one that's contributing to this, and pickup C is also this one. Okay, so this is also mutex. Yeah, okay. So which of the following are applicable actions in NOOP 2? I'll just write mutex, not mutex, not mutex, mutex. Maybe I should even take a screenshot of this and add that. So what is this question asking? Which of the following are applicable actions in layer 2? Applicable actions in layer 2. Okay. So now we extend this that okay, now some layer 2 will be occurring, right? So let's just check each
no,
of
no, there is further in the single before we applicable action is just the preconditions should exist, right?
yeah.
But now those preconditions should be non-mutex.
Yeah. So what this says is pickup C and unstack AB are mutex because condition 4 both consume that. Mm. So for an applicable action, firstly, the preconditions should be in the current state, and there should be no pair of preconditions that is mutex. Yeah, or no? If all combinations of A, B. Okay, so if we can even find one non-mutex pairs, then we can say that action is applicable in layer 2. Okay, so let's try that. So what pickup A has as preconditions, let me write this properly, that preconditions of this is equal to, what are the preconditions? Arm empty,
Clear A,
clear A,
A on table.
on table A. Yeah. So now we need to check each action that is causing these prepositions to be in layer 1, and for these actions we need to make pairs of them and check whether if even a single pair is possible such that both actions are not mutex. Okay, so action pairs for the first pair would be, so arm empty is an effect of these two. Yeah,
Clear A,
and these two and these two. Oh wait, and these two, right? So action pairs, if I'm writing, I'll write them as,
3 pairs, no?
that's just for arm empty.
We have to take 2 propositions from the preconditions.
I'm not getting what.
We have to take 2 propositions. How is applicable? What is the definition of applicable actions here?
Applicable actions in the case of graph plan, not graph plan, in the case of goal stack planning was that
Preconditions should exist.
yeah, here the definition is not given.
But here some special definition is there for applicable action. I
Yes,
don't
that the
remember.
precondition should exist as well as the preconditions should not be pairwise mutex. Yeah, so meaning that these guys should not be pairwise mutex.
Okay, for the first pair, what are the? Let's check how many pairs are 1, 2, 3 pairs are there.
3 pairs, yes. I mean, the intuition behind that is that for any action to be applicable in layer 2, those the preconditions for both of these actions should be present in layer 1 in a valid format. Yeah, that's why we don't want there to be that's why even if there is a single pair of prepositions that is not mutex, we are fine. Wait, the next one would be on table A and arm empty, right?
Correct.
So these are not action pairs, we just pairs. Okay, so is arm empty and clear A mutex? Arm empty and clear A, I believe so. Wait, what was discussed about this in that TA session Bhaskar sir took on Sunday? Because there he solved this
Yeah.
example, yeah?
You only asked this question, no?
Yeah, and I forgot.
I also forgot.
And there's no recording as well.
That is the bad part of the session.
I'm confused whether he was talking about action pairs or whether he was talking about preposition pairs. I think it was about prepositions, right? Okay, let's just check preposition pairs. Let's just check what the answer is firstly for this. It is pick up C, put down C, and stack BE. Okay, so let's check these two first. Like, are these two mutex? So arm empty and clear A. Arm empty, clear A. Are these two mutex from earlier? Earlier what we were comparing? We were comparing such ways. Okay. So arm empty is a negative effect of these two actions, these three actions, yeah? While clear A is a positive effect of these actions. Okay. Oh. I'm not actually too sure like what to do here.
Yeah, I'm also.
So one thing I
1
think
minute, I will
was
ask
is
ChatGPT.
sorry.
I will ask ChatGPT.
So one thing I can see here is that arm empty is okay, no wait. Arm empty is a negative effect of this, negative effect of this, and a negative effect of this, while clear A is a positive effect of this. Okay. And for any proposition, if are mutex if all combinations of actions in AI for which okay, no, got it. Okay, so what we are being asked is that we have to check whether these two are pairwise mutex, yeah? And the action which has arm empty as a positive effect is no op 3, okay? And the action that has clear A as a positive effect is unstack DA, yeah? Is that clear? And from earlier we know that no op 3 and unstack DA both are mutex actions, okay? So because of this uh, these two propositions are mutex, okay? These two propositions are mutex because no op 3 and unstack DA, the two actions that have these two as their positive effects, these two actions are mutex themselves, okay? So now we move on to this pair, clear A and on table A. So clear A is a positive effect of unstack DA and on table A is a positive effect of no op 8. And no op 8 and unstack DA don't even have anything in common in the preconditions or in the positive effect, so this is not mutex.
Yeah, Ishan, we want all pairs in the precondition should be non-mutex.
All pairs to be non-mutex
Yeah, for applicable action,
or just one?
not all pairs. All pairs should be non-mutex.
Okay.
So since we already got mutex is for first pair, we can discard that action.
but we know that this action is applicable. Okay, yeah, so this is not applicable. Okay, yeah. Okay,
Let's
yeah, makes
take the
sense.
pickup C action now.
Because of this itself, because we know that these two prepositions are mutex, we can discard. That's what you're saying?
Yes, because all pairs should be non-mutex to be applicable.
Okay, yeah. Now that makes sense. Okay. So all pairs should be non-mutex. So that's why I compared the first two pairs and found them as mutex. So that's enough of a reason to discard this. That this is not an
Discarding.
applicable action. Okay. So
Let's
then,
do fresh for the pickup C.
yeah. So now second option would be pick up C. Yeah. So preconditions for pickup C would be arm empty, clear C, and on table C. Correct?
Again, we have three pairs of preconditions.
Yeah. So we have the exact same three pairs like this.
Variable will change, no?
Yeah, just the variable will change. So this is C, this is C, this is C, this is C. Okay. So now we again check whether arm empty and clear C are mutex propositions. Okay. So arm empty is a positive effect of no op 3 and clear C is a positive effect of no op 7. Yeah. And these two actions are non-mutex. So because of that, this is non-mutex.
Yes.
This is non-mutex. So unfortunately, we'd have to check for two more.
Understood.
Yeah, for the next one. So the next one is clear C and on table C. Clear C, on table C. Again, these two are non-mutex. Okay. Because what I'm doing is that I'm just comparing the two actions who generate these two prepositions as their positive effect, and I'm just seeing whether these two actions are mutex or not. So no op 6 and no op 7, these two are non-mutex because they don't have any of the similar they don't have any similar precondition or any similar they don't have any common precondition or any common after effect. So that's why. So I'll have to also check for on table C and arm empty. So on table C is being generated by no op 6 and arm empty is being generated by no op 3. Again, two mutex actions, two non-mutex actions, right? So this is also non-mutex, so this is an applicable action.
All non-mutex, so applicable.
Yeah, so this is applicable. Let's see put down C now. Now pre of put down C is that firstly it should be holding C. Yeah. And that's it, I think. Yeah, that's the only condition. Yeah. So now because there's just one condition, of course it is going to be pairwise mutex with itself, pairwise non-mutex with itself. So that's why it's straight up applicable. Now the precondition of stack BE. Precondition of stack BE is holding, that it should firstly be holding B, right? It should be clear E, correct?
Should it be arm M? No. Yeah.
Yeah, that's only these two. Holding B and
Only
clear
one.
E. Okay.
Only one pair.
So there's only one pair here to check. Holding B and clear E. So holding B's precondition no, sorry, holding B is action, the action that is adding holding B is unstack BE. Okay,
Clear E also same.
and clear E also has the same action. So unstack BE will definitely be non-mutex with itself.
By itself. Correct.
Yeah, so because of that, again unstack BE is valid. The fifth is stack CE. So pre of stack CE. So it should be holding C and E should be clear, right? So holding C and clear E, which basically becomes holding C is being added by this and clear E is being added by this, correct?
These two are mutex.
And these two are mutex. We already know that from solving earlier. So that's why this is also non-applicable. Okay? Mutex.
Mutex.
And that's why that way. Okay. So I'll just make a note down here. Two prepositions are non-mutex, are mutex only if all actions, no, if all pairs of all actions
Are mutex.
no, adding them to layer, that they should be positive effects of these actions, right?
All actions adding them to the layer.
Are mutex.
No applicable action.
Yeah, so now for applicable
After.
action, an action is
An action is
applicable
graph plan only if
in graph plan when,
all its precondition
yeah,
should belong to previous
all
layer and
preconditions are in the previous layer.
it is important. No pair,
All, yeah, no
all
pair,
no pair is mutex.
no pair of preconditions is mutex.
Otherwise, all pair should be non-mutex. In bracket, you can write.
Yeah. Okay, so that's how you solve graph plan and that's how you solve AO star. So there's this entire thing left, but honestly I don't have the energy left to do it anymore.
Okay, let's meet tomorrow, no?
Yeah, let's meet tomorrow and do a PYQ maybe.
PYQ and AO star.
Like I'll solve this at night by myself, I think, maybe, and we can discuss solutions, but otherwise maybe we can just go ahead with PYQs now, because AO star was, it was not fully clear, I'll say. Or okay, maybe we should just try this example and then we can finish the session. Yeah, maybe let's just wrap this.
Isha, are you recording this session?
Sorry.
You are recording this session, right?
Yeah.
Okay. Because अभी मेरा सब bouncer जा रहा था तो I have to go through it again.
Graph plan है ना?
हाँ. I find it mutex thing a little tough.
Okay. I don't know how to boost my volume for this, because for some reason I believe even the system audio is being counted as mic audio. Like whenever you were speaking, the mic audio was also bumping up, and I think that's what amplifies other people's voices except mine.
Oh, okay.
Okay, so anyways, this, yeah.
And this PA is having step-by-step answers, no?
Yeah,
Questions.
I think
Hopefully, we will learn better.
that's why I was more convinced to, okay, let's just do this right now, because I think it will help a lot more. Because I think graph plan is clear. Like a few more practice, but otherwise it's clear. But AO star maybe a little bit. Okay. So PA AO star. So the figure given below is an, okay, just allow me a moment. Okay, so the figure below is an and or graph that depicts how a problem S can be decomposed and transformed into one or more simpler problems. Each node has a label S, A, B. Each node has a label S, A, B, and so on. The number in each node is the heuristic estimate of the cost of solving that node. Nodes in double circle are primitive nodes and their values are actual costs. Observe that a primitive node is added to the graph by its parent when the parent is expanded, and the primitive node is labeled as false, and it will not be expanded subsequently. So tiebreaker 1, for nodes with the same cost, expand in the ascending order of the node labels. For AND nodes, expand the branch with the highest cost.
Okay, highest cost. And H cost they have not given, right? No H cost.
I think they might be given for the two cases described below. Answer the following question.
Acha, hai. Cost has 2 units. Okay, fine.
Yeah, so in the given AND or graph, take the edge cost as 2 units. This is important to not forget in the exam, that do not assume this to be 0.
Yeah.
Yeah, okay. So the initial cost of S is 32. After expanding S, the revised cost is. Okay. So I think a better idea would be to draw the graph by hand, like I did previously, because that's how we were able to solve it. So this is 32. Yeah. So this 32 becomes expanded in this way, that a 20 is here. 36 is here, and these are AND. Then there's 74 here. Then there's 60 here. Yeah. So the costs that we'll be dealing with right now, because the edge cost is 2, I'll write that here. Edge equals to 2. Okay. So the cost that we are dealing with here is 56 plus 4, 60 here,
Hmm.
76 here, and 62.
Yes.
Yeah.
Yes.
So we'd be updating this to 60
Yeah.
and we'd be going this way.
Hmm.
I'll write this properly as this, that we are going this way right now. Okay,
Hmm.
and we'd be exploring this next. So the next cost should be 60. Good.
Yeah.
After expanding, the children that are marked by AO star are AO star. What does that mean?
Tables.
Means the
So ABCD.
20 and 36 here to expand ahead, no?
Yeah, so only A and B, right? Because that's the one that we have chosen. Yeah, A and B. What is the second node expanded by AO star? B.
36.
Yeah.
B.
Yes.
After the second node is expanded, the node is revived and the change is propagated to S. Enter the cost of the second node and the revived cost as a comma separated value.
Okay.
So now we expand this further and this leads to this 30 here, which is a primitive node, by the way.
Hmm.
This is a 30. So we go this direction as well as
Yeah.
this direction. Correct? Now I'll just
Together.
56 here. Yeah? 56.
Yes.
So the cost here is 30 plus 56, that is 86 plus 4, 90.
Yeah.
Yeah? So this is 90 now. This is 90. And this now new cost becomes 114.
Yes.
Yes? So now this new cost becomes 62. Okay?
Hmm. Yeah.
So enter the cost of the second node, 90, comma 62. Yeah?
Hmm.
90, comma 62. Okay?
Hmm.
After the second node is expanded, list the nodes that remain on marked paths.
D, no?
No.
What is marked path?
Marked path is the red one that I'm marking.
No, but now we have changed it, right?
Yeah.
It's going to 62, so it should be.
Yeah.
Shouldn't it be D?
So it should be this, this, and this. Okay? So A, D, and F. Hopefully. Otherwise it would be confusing. D, E, and F. D, E, and F. Why not A?
Because you already gone ahead, not to E. So it should not be there, I think.
No, we never even expanded this.
Oh, okay. Yeah.
After the second node is expanded, list the nodes that remain on marked paths. When you are saying that B would be the node that would be expanded, this B, and that leads to E and F, yeah. So E and F are in the marked path. Okay, got it.
What?
Okay, so we only count the deepest nodes, right? Like if we were
Okay.
to return back to the left side, we won't start
Oh,
here,
I
we'd
see.
start here. Yeah? Because currently we are expanding this node, and for this node these two are the more important ones. Yeah? That only when these two nodes are solved, we'd mark this as solved, correct? But now
Yeah.
that we have moved to the right side, this is the one that we are solving for.
Yeah.
This hasn't even been touched yet, so that's why it's not in the path right now.
Okay.
It's not even touched yet. So that should be the case. So it should be D, E, and F. Okay. Let's see if there is a similar question down the road and we can use a similar logic for that and solve that as well. Starting with F, determine the nodes expanded by AO star. List the nodes in the order they are expanded. Observe that primitive nodes are not expanded. Starting with F, determine the nodes expanded by AO star. Like, do we need to solve the entire thing now?
Yeah,
Seems like.
Okay. Okay. So now we are at D, correct? Because now this is the one that we are solving. So this is the one that we are solving. So this leads to two more paths, 24 and
But shouldn't we write the earlier one solved so that it will be in the order as well? Like S, B, something like that.
no, observe
Starting with
that
S, it is.
we'd write that afterwards. Let's just solve first. So
Okay.
the cost here is 24 plus 36, that is 60, and 60 plus 64. The cost is 64 here, correct? And the next one that we solve is this one. So firstly, this is no wait, yeah. So that's the one that we'd be solving next. So now the cost is 64. So we should update this to 64. And if we update this to 64, this thing becomes, what does this become? 66, correct?
Yeah. Yeah.
Now if this becomes 66, this is 114, this is 76, so of course it will pick 76, right?
Hmm.
76, and now it explores this instead. Okay, that's in the marked path now.
Wait. Why not that 66 thing only it took? Why did you go to 76?
Oh, right,
minimum
sorry,
66.
yeah.
I
Yeah,
was confused.
66,
No.
yeah. Yeah, sorry. 66. So we explored this thing now, and we are already
Hmm.
at this. Okay. So now we expand that 36 down, and we get a 40. That down there we now expand to this portion 40, and this is a primitive node. So because of this,
Yeah.
now this turns out to be, this ends up becoming 42,
42. Yeah.
and this is solved.
Yeah.
Okay, so it was asking about the order in which they were expanded, right?
Yeah.
Okay, so that's what they said. That okay, so firstly we expanded S,
Yeah.
then we
Then B.
expanded D, right?
Yeah. Then E. Yeah.
No, we did not expand.
No.
Expand this.
It is in the order of solved notes or expanded notes. Just check what they are mentioned.
Nodes that are expanded, and observe that primitive nodes are not expanded. So this is not expanded.
Okay.
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 So we move to D, right? Then we move to I. Okay.
Hmm.
And now
Yeah.
that this is 40, this is 42. The entire weight now this becomes 42 plus 24, that's 66. So this becomes 66 plus 4, 70.
Hmm.
Yeah.
Yeah.
So
In
this
that
is
circle of 64. Yeah. Hmm.
70, and this now ends up becoming 72.
Yeah.
And this becomes 72. So we still expand this now.
Yeah.
Okay.
Yeah.
Now we
Hmm.
come back here that okay, this needs to be solved, and we see that this is left. So we
Hmm.
expand this, right?
Yeah.
And when we now this is in a marked path and we expand this and we get two options and 20. So of course it will pick 20, this one,
Yes.
and
Yes.
then it also becomes solved and its weight is 22 now.
Yes.
Now 22 plus 42 is 64 and 64 plus 4 is 68.
Yes.
So 68, and it would also be solved because its successors are solved,
Yeah.
and after I we expanded h. Okay,
And your S pay you have to write 68 again.
yes, I was
Sorry,
turning
70, 70, not 60. 70.
so this is 68 plus,
No, that is 68, right?
that is
It is
68, yeah.
right.
So
At
68,
S you have to write 70.
now this again becomes 70.
Hmm.
Yeah, and 70 is still the smallest one,
Yeah.
so this is marked
It
as
is
false.
stop now.
Yeah.
Yeah. It is done, no?
Yeah, because this is the smallest one. If it wasn't the smallest one, if someone else would have been the smaller one, then
Yes.
we would
It
have
would have
expanded
gone
that.
there. Yeah. Yeah. Right.
Okay, so this should be SBDIH. SBDIH. Okay, that's correct.
Yes.
Okay, determine its value after expansion for each node. Okay, so S after expansion becomes 70.
Hmm.
I think they are talking about the final value, correct?
I think so, yeah.
So for B2 we'd count, right? Even though we did not explore B as much, 90. Then for
You have to write
E,
for
it should
everything?
become
I
68.
doubt.
Then for I, 42.
For
and
each node,
then
okay.
for H, 22. Let's see. We did something
Uh,
wrong.
Accepted on. Okay.
It should be 60, it says.
60. How?
I think it is asking for after
42.
solving the graph, right?
Sorry?
This is asking for the information after solving the graph.
Yeah, after solving the graph.
But
Okay,
we are yet to explore, no?
so 42, 22 is correct. Okay, so far we are correct. I think going upwards we made a calculation mistake. 22 plus,
I think the 90 is also correct somewhere. There was no 90 also, na, for D.
yeah, 90 is also correct. So 64 plus 2 plus 2, it should be 68, and then again 2, so it should be 70. I don't see how 60 should be done.
Exactly. How can that be 60? 80, 90, 64. 64
If
कहाँ
you're
से?
saying that these two are correct, if you're saying that these two are correct, these two should be 22 and 42, then of course this thing would be 22 plus 42 plus 4. 22 plus 42, 64 plus 4, 68. So how are you saying that this is 64 instead?
And for which year he's saying 64? For which one?
D, this one.
D. And if D is even 64 according to them, how can S be 60?
Yeah, it
Should be
should
more
be.
than.
Yeah, it should be 66 at least.
टाइपो है ऐसा मुझे लग रहा है. I don't know.
This course. Quiz 3 syllabus.
That's what I was talking about sometime ago.
So interesting question. Who asked this?
I don't know. Whatever
Who's
whichever time I have
okay.
attended, I have never come across any student who is asking for interesting paper.
Yeah.
That to do Bhaskaran sir, impossible.
Yeah.
Mm. He has taken it to heart, I think, whatever has been discussed with him. So seems like
Yeah, like in Three Idiots, Virus made a special paper
yeah,
for Raju.
exactly, exactly.
And that's what he's doing.
But from that yesterday, when we were discussing about him, one shot again I remembered from Three Idiots. I want to tell you how to teach students. That one.
Yeah, that you know better AI than me. There's no doubt about that. I don't understand how BNB went. No, that's too old.
And the way he was answering that day na, on in the session, at that time I felt like saying, ki, I want to tell you how to teach students. That's it. Baki to you know better than us in AI, but you don't know how to teach students for sure.
Yeah. Oh wow, nice post. Keep it up. Oh yeah, this is the one that I did in the previous session.
Oh, he's very happy with you actually.
Yeah, me and Sujay were like stressing over making this post as perfect as possible. So uh, so no one asked this. Yeah. So maybe
How should we
time
go
for a
about
new
this?
post then. Week 9 practice assignment 2 AOSTA. Okay. Uh, for the given question, this is the expanded graph. For the given question, this is the
I think
example.
you should copy that original thing as well for the reference.
Yeah, okay. Original question graph.
Ishan, it is suggesting some the post C week
That's
9 practice
statistics,
assignment.
right?
Oh, okay, okay, different. Sorry.
My solution. So it's this, and what I basically say is that okay. So the question is asking. So the question is asking us to solve the to perform a star on the entire graph till until S is solved. Mark as solved, and then uh, question 7, right?
If instructor taught us this well, then we wouldn't have spent this much of time, right?
Maybe, huh? I should have taken a better question, a better screenshot. Okay. The question is asking us to perform on the entire graph until f is marked as false, and then write the values of the expanded nodes. Expanded nodes F, T, no. What's the order? F, E, D, I, H. The question is asking us to perform AO star on the entire graph until f is marked as false, and then write the values of the expanded nodes f, d, h, I in that order. For my solution, I am getting the values as while the solution says the values would be okay. My doubt here is that no, what I can say that the values for nodes I comma h match for both my solution and the correct solution. So we know that these nodes cost 22, 42. Which one is I? I is that one. No, 42, 22. 22. Oh, okay. I should maybe write the node labels as well here. S, B, D, I, H, L, K. Okay. I'll take another screenshot of this. As D is the parent, of both H and I, and the edge cost equals to the cost of D should be 42 plus 22 plus 2 plus 2 equals to 68. So how is it? So how is the correct of value of D 64? What's your question? reach D only through an edge. Reach D only through from F E through the edge FT whose cost is 2. So the value of F would always be greater than value of D, but in the solution the value of F is 60, which is less than the value of D mentioned in the solution itself. Is this a typo or as intended? Okay, is that good enough? If we were to assume the value of D is 64, then as per the graph we can reach D from F only through the edge FT whose cost is 2. So the value of F would always be greater than the value of D. But in the assignment the value of F is 60, which is less than the value of D. D 64 mentioned in the assignment solution itself. Is there a typo or my solution assignment solution? Okay, I think that's good enough. We spent a lot of time on that. Anyways, so this question now. Let's just assume that this is the correct one because I don't see how F can be 60 when D is 68, right? When D itself is 64. So after A of star expands a node, its value is updated and the change is propagated to the root. Oh, is it after every expansion? $70 now, but still 62. Okay, to list. Okay, no, I think the solution is fine.
Means
No. What they were asking here wasn't the final thing. They were just asking expansion
the
value
intermediate
after
ones.
one. Yeah. Because here too you can see that here they are asking the value of F after every expansion. So in the last one you can see that it's 70, which is correct.
Okay.
Okay, then all that time
But
We
running.
still,
have to
that 60 is a mystery. 60 can no way come, no?
No.
At the most,
That
it should be
60
62.
comes from this. That 60 comes from this.
Acha, D. Okay, D का है वो.
This.
then we have to keep track of every
Ah,
Yes, we have to keep
OMG.
track of everything.
Wow.
Let's just do that very quickly on the graph itself, okay? So,
Okay.
so this is 60 here, right? This is 76 here. This is 62 here. So this becomes 60, okay?
Yeah.
And we pick this one because that's the one to we pick this as the one to expand. All right.
Hmm.
And there's also this one that we'll expand later. So now we are expanding this, and here we see that there's just only one possibility, and that is this. This is an AND node, okay? So 30 plus 56, that is 86 plus 4, 90. So this cost is 90. So this updates to 90, correct?
Yeah.
This gets added, this gets added, correct? And this is already solved. So this is marked as 90. Now we go way up there, and this entire thing updates to 114 because 20 plus 90 plus 4 is 114, yeah? And the minimum one here is 62. So this updates to 62.
Okay.
Okay, so we now expand this thing. So we now expand this, and 62. So 62 is no, wait, sorry, D. So now we expand D. So it's the actual cost turns out to be 24 plus 36, which is 60 plus 64 plus 4, 64. Yeah. So this is 64, and we expand these two. This becomes 64. So because of this, this cost becomes 66. Yeah.
Yeah.
And this becomes 66 because it's the smallest one out of these three. Okay. So now we expand this one, and we see that it's 40 down here, and this is a solved node. We add this, so this becomes 42. Correct? And similarly, we go up now. So now, because that became 42, 42 plus 24, that is 66. Is it 66? Yeah, 66.
Yeah,
plus
66,
4, so this
58.
becomes 70. So,
Krishna, you
70, yeah.
42. It's all no.
right, this is also solved. Yeah. So this is also 70, and this is also 70. Okay.
Yeah.
So now this is 70. Now then we solve this one, and because this is solved, this becomes 22. This is solved, and we go this way. We went here because that's the best value, right?
Yeah. Yeah.
So now because this is marked 22, now 22 plus 42 is 64 plus 4, that now this becomes 68. Yeah. Now this becomes 68, so this stays 70. No,
And
wait,
this is
wait,
H is
wait, wait,
solved,
wait.
no?
No.
What happened?
So this is 42. So 42 plus 24 is 66. So this should become
Yeah.
68, right?
Yeah.
So why did I write 70 there? This is 68. So this becomes 70.
Yes.
Right?
Should be.
No, sorry, this should be 70 now. Because 4, not 2. 24 plus 42 plus 4. So 22 plus
66
44 is
plus 4.
66 plus 4, 70. This should be 72 and this should be 72 now.
Okay.
Yeah, but now that we come here, we expand this becomes 22. This value drops down to 68 and this value becomes 70. Yeah,
Mhm.
and at the same time this entire thing was solved, this was solved, because of this was solved, because of this was solved. Okay,
Yeah.
now I think the question
Mm.
was here was asking the first expanded value of every node
Okay.
in the path.
लास्ट का अपना राइट आ रहा है क्या? Just check.
Previous question.
So 60 because that was the first value of f. Yeah, the first
Mhm.
value of b was 90, so that's why 90 there.
Okay.
The first value of d was 64.
Oh, okay. You're right.
So
Written that
64
way.
there.
Okay.
First
Hmm.
value of I was
42,
42
yes.
and then 22.
Wow. Okay.
Now that makes
What
sense.
is
Now I
right?
can just happily delete this.
Okay.
So the past 15 minutes I spent writing that, useless. So now this is talking about all the values of s, right? So we have this right here: 60, 62, 66, 72, 70.
Yeah.
Which now matches.
Oh, yes. Yeah.
Now list the nodes in the solution found by A of star.
Hmm.
S, D. Okay, no, so in ascending order, right? So the solution is this one. So
Yeah.
this is what would be the ascending order? D, H, I, K, L, S, right? D,
Yeah.
H, I, K, L, S. Yeah.
Cool. Okay.
When A of star finds a solution and is about to terminate, what are the nodes that remain on the marked paths? These two.
Yeah.
E, F.
E should be solved, right? The last one.
Yeah, but it's still on the
E.
marked path because earlier we kept it on the marked path here.
Okay.
Still don't understand what is.
Yeah, don't understand. Yeah.
See, I told you this is the path in which we have the one which we have
Okay,
solved,
so
right?
we also have to consider the solved ones as well.
Also means E and F was there already in that.
Yes, E and F we already
Oh.
considered them and enough marked path. So we have to consider these
Okay.
as well as these.
Hey, Bhagwan. Okay.
So list in ascending order. So I'll just write D, E, F, H, I, K, L, S. Isn't that the answer? Yeah, that's the
Okay.
answer.
Yeah. Right.
Okay. Then what is this? In the given AND OR, take the edge cost as 10 now. Okay.
Wow.
Take it as 10.
So time consuming, all of them, like, my God. All the AI things are very time consuming. कैसे
So
करेंगे
I
बता
won't
दो।
make the graph for this. I'll just solve it on here itself. Yeah.
Yeah.
So now we are just to assume that the edge cost is 10 now.
Yeah.
Edge is 10. Or no, maybe I should make just for practice. We start from 32.
Hmm.
We go to 20. Then we go to 36 as well because it's an AND node. This. Then we go to 74.
76.
And we go to 60. Okay. Yeah. So so now this is 20 plus 36 is
56.
56 plus
Plus
20
20.
76, right?
76. Yeah.
So this should be 76 cost right here.
Yeah, it will be 84 and 70
Should be
respectively.
84 and 80. No, just 70.
70. Yeah.
Yeah. So we expand
Total
this way.
70. Hmm.
Okay. So now we expand this way. So our next path would end up becoming 24. No.
No, 36 first. Okay.
Yeah. So 24, 36. Yeah. So now 36, 24 is, and yeah, this is an AND node. So
And
24, 36 is 60. 60 plus
36.
20 is 80.
88. Yeah.
80. So this becomes 80.
Hmm.
And we expand this one next.
Become 90
Yeah.
for the upper
So
one.
this thing becomes, the cost becomes 90.
Hmm.
So
It will
we
shift to
skip this and go
76.
here. So here,
Yeah.
right? We add this
Hmm.
to our marked path. And then from 36, we have,
You're not tracking starting node values. You've gone-
oh right, I forgot that. So this earlier changed to 70. Yeah. And then it changed to 76. Is that correct?
Not remembering like when it started
Because
to
earlier we went this way, now we are going this way.
70 barabar hai,
It
right?
took 90 in between, no? Or no, we did not take 9. Okay.
No, we didn't take it, no. We just calculated it.
Right.
Yeah. Sorry. Got it.
70 and 76. Yeah. So now from 30, so we end up with a primitive node here. So that is a solved
Hmm.
one. And this
Yeah.
is a 56 and that. Okay. So now
Hmm.
this is again an
And-
AND
and-
node.
Hmm.
So the cost is
40.
84, sorry, 86 plus 20, 106.
104. Oh, sorry, 156 hai, 106.
106. Yeah. So now
Hmm.
106 and 20 is 126. And on that we
146.
again add more 20, so 146.
Yes.
146.
Hmm.
Okay. So now you change this to 84. That,
Yeah.
yeah. That I am going to expand this thing now.
Hmm.
74, and then we go from here to these two nodes.
It's unknown.
Yeah.
It's going to 26, the other one, not
No,
56.
26, yeah. So here and here.
Yeah.
26 and this, right? So 26 and 24, that is 50 plus 2, 70.
70. Yeah.
No, don't erase that. 70.
Then
This is
80.
80. And this is still the smallest one.
Yeah.
80.
Yes.
Okay. Now that we are here, so we'd expand this one because that's a bigger one.
Hmm.
Yeah. So
You need to expand 26 now because it's
26.
Oh, right,
Yeah,
okay.
not 24.
I don't know why I said that's the bigger one. Okay. So yeah, 26 there. Now we expand this, and that leads us to a 50 down here and a 20 down here. Right?
Hmm.
So now this thing becomes 30
Yes.
and it gets solved.
Yeah.
Yeah. Now because this is 30, that is 54 plus 20, that's, we are back to 74.
Hmm.
Yeah. And we are back to 74, so this becomes 84.
Yes.
And this is again 84. Okay. Yeah. So
feel that is the best.
this is the best. Next. So we expand this, and this leads to here.
20.
And
Yeah.
40. Okay. So this
Hmm.
loop takes up the value 30.
30.
Yes.
don't do that.
And it's
So
solved.
yes, and even this one
30
was
plus 30.
26 earlier. It became 30 later.
Hmm.
Yeah.
30
When this
plus 30,
becomes 30
60,
later,
80.
this is marked as solved. So now because this is marked as solved, this is also marked as solved, and 30, 30, 60 plus 20, 80.
Yeah.
This is 80
Hmm.
and this is 90.
Yeah.
So now we have a 90 here, we have a 90 here, but because both are the same cost, we mark this as solved and update
And it
this.
is done, na? It has reached to the primitive node. It's complete.
Yeah, and so that's why we make this a 90 here, right?
Yeah.
Okay, so let's see if we are correct on this. Initial cost of, okay, so after expanding, the revised cost is 70. After expanding, F, the children that are marked by AO star are AB. No, no, D, only D. Because we first went in this direction. What is the second node expanded by AO star? So after this was expanded, what did we expand? We expanded this, right? B, because the cost became something like 84. So that's why we moved on to this part.
Yeah.
So B.
T.
Okay, so after D, yeah, so okay, F is the first expanded node, then D. Okay,
Oh.
forgot that. After the second expanded node, the second node is expanded, that node is revived and changed if propagated to F. Enter the cost of the second node and the revived cost of F as a common list. Okay, so it changes to 60, right? No, it changes to 80 because 36 plus 24 is 60 plus 10 plus 10, 80. And the revived cost became 76, this one. Yeah, 80 and 76, 76 came from the left hand side, this part.
Hmm.
After the second node is expanded, lift the nodes that remain on the marked path. So after this is expanded, what are the nodes that remain on the marked path? H remains, that's it. Only H. No, everything, count everything for some reason. Okay, this is a confusing thing for me. Because in the previous one we did not count A, now we are counting B. Okay, yeah, okay, no, that makes sense, I did not count A. So after this is expanded, we propagate the change upwards, make this 76 and then go in this direction. So that's why AB, H, why I too? We did not even touch I. Okay, no, but it was there for expanding, right? That's why this symbol. This is a bit confusing, I think. This would require some practice. ABSI. Yeah. So that happened. And starting with D, determine the nodes expanded. No, starting with F, determine the nodes expanded by AO star. List the nodes in the order that they were expanded. Ah, shit, we did not write the order. We were too I was too focused on keeping track of these values that I did not keep track of the order itself. So let's just guess that it was S, D, then B, right? S, D, B, then we came here again and then we expanded expanded H. Correct? Yeah, FDBC GH. Yeah,
Hmm.
that's correct. Okay. Now for each node in the previous question, determine its value after expansion. So that's something I kept track of here. So 70 first, then 80, then 106, then 70, right? '70.
I think so. Not sure.
Then G would be this one, so 30 and 30. Yeah, absolutely correct. After AO star expands a node, its value is updated and the change is propagated to the root. Lift the value of the root after every expansion. So 70, 76,
84, 80,
84 again,
84,
and then
90.
yeah.
Cool. Yeah.
List the nodes in the solution found by AO star. So this is the one that we found. So CGHK, CGHKS. Yeah.
Hmm.
What are the nodes that remained on the marked path? I don't know.
No, we have to write the entire,
E,
consider entire red things and that 30 thing also.
yeah. So E, F, and this, I'll say. That E, F, I. Oh, sorry.
नहीं,
The red
बाकी
thing
का भी
too.
करना
Yeah,
है.
you said to do
Yeah.
that as well.
Yeah.
So C, E, F, G, H, I, C, F, G, H, I, K, J, L as well, right? No, J, K, L. No. So till HI is clear that okay, firstly include these ones. CGHK. So include CGHK and then yeah, okay, K. Just add K. Okay. So the ones that were in the path, this path, and these three. Yeah. So CEF, GHIK. Okay, so that's AO star done. Okay, so I think I am partially confident in AO star now and graph plan as well. It's
I'm
5.
partially confident in AO star, but graph plan I have to again go through it,
Yeah.
going above my head, actually.
So Ishan, you are not taking another session for AO star and graph plan, right?
Yeah,
Last.
because now we just did that, right? So anything now would be overkill. Maybe it will be better to practice through PYQs themselves.
Aren't you guys going to check the slides as well?
Slides for
Because for definitions and all that stuff, because since it was mentioned in that
I am thinking to do
discourse
it.
post.
Thinking to do it.
Pardon me?
I am thinking to go through slides.
Yeah, I'm also thinking, but I'm just into two minds